Hello everyone, my name is Rayya and I will be continuing what Philip has started by giving an update about the work that has been done in Nfdi4chem in terms of standardizing NMR metadata, which will cover basically the NMR minimum information and also curating nmrCV. So in Nfdi4chem, we have been working on providing minimum information about chemical investigations, which we call Michi, in different areas of chemistry. And one of these areas is basically the NMR, which resulted in our new standard that we call Margaritas. And it covers NMR assays for liquid NMR and small molecules. And initially, we provide our minimum information schema as a table. And this table provides the properties that we are requesting and the level of mandate if they are mandatory, optional, or recommended. And also the definition of these properties and the accepted values and other different details. And this was our first minimum information we provide. So we are using this kind of template to create the rest of our Nfdi4chem schema. And in this schema, we are also trying to incorporate ontologies. And there are different ways to incorporate them. First, there are the definitions. So for instance, when we ask for like the NMR solvent or when we ask for the NMR sample tube, we could provide the definition of these properties from ontologies. And the other way, which we are also using, is the export format, which basically represents the accepted values in a specific field. For instance, when we request the user to provide compounds, we ask them to provide them from KBI. Or also when we request some units, we request them from the unit ontology. We are also looking into using LinkML to formalize the minimum information schema, and this will enable us to export the metadata in different formats. And these formats include RDF, Turtle, JSON LD, and also will be able to validate the exported metadata against the schema using JSON schema and Shackle and Python. However, when we were trying to map our minimum information schemas to an ontology, we had several issues basically related to incompleteness. So we find missing classes and individuals, also annotations, and sometimes we need to rely on different ontologies, and sometimes they are not compatible with each other. Also, there are issues with incorrectness related to the use of annotation properties, also the definition synonyms, and cases of imprecision and irrelevance. And we have faced the same issues in nmrCV. So nmrCV, it started as a huge effort to provide control vocabulary in the field of NMR. But because there is lack in maintenance, the issues accumulated there, and we needed to find a solution in Nfdi4chem. And here we could see some of these issues. For instance, if we look into the NMR solvent, we could find only 3 values there, but in reality there are much more. So there are a lot of missing classes and individuals. Also, sorry. Also, there is incorrectness in the use of annotation properties. So if we see the description field, we could see that a definition is provided within the description, while they were supposed to provide a definition field, for instance. There's also incorrectness in the use of synonyms. For instance, here we have the calibration compound, and it's a parent class, and one of its synonyms, reference compound. And then if we look into the children of calibration compound, we see one child that has the synonym reference compound again. So the parent and the child are provided as synonyms. Other issues we had is the individuals. When it comes to NMR instrument manufacturers, we have found several instances where we have software provider, or we have DNA and genetics instrument manufacturers, X-ray, chromatography, MS, UV-Vis, and also MRI. The list is longer, and also we have other instances that we needed to remove. When it comes to irrelevance, we could find this with the chemical compounds. So nmrCV is focusing on NMR, and it's not supposed to have chemical compounds. It's not specific in this domain. And this results in lack of chemical annotations and lack of cross-referencing, and also some incorrectness in some cases. Also, there are issues with imprecision. So here we could see a definition that is too long, and it includes some inaccurate details. Also, it includes explanation and examples, which are not supposed to be in a definition. Because of all these issues, we needed a solution Nfdi4chem for nmrCV. And actually, we have started working on this since last year with a discussion of the overlap between nmrCV and CHMO. And highlighting the importance of nmrCV for the NMR metadata, and then making the decision that we need to reboot nmrCV. We started the development with Dockerizing nmrCV with ODK and following OBO foundry principles. And one of the main goals here is that to make it compatible with other ontologies that are relevant for this field, like CHMO. So the workflow here is that we have some issues in nmrCV. We go and discuss them with field experts. We provide the solution in nmrCV, and this solution is then possible to be re-imported or exported to CHMO. And some of the areas we have focused on, first, the chemical compounds in nmrCV. As we mentioned, they were not supposed to be declared there. And the main compounds are NMR solvents and the reference compounds. So what we have done is collecting and curating different instances and individuals of these compounds from repositories, standards like AUPAC recommendations, and from field experts. And also we have curated them and tried to align the axiomatic definitions with the textual ones, and distinguishing between the materials and their roles. And we have submitted this work to KBI, and after it was approved there, we have re-imported it to nmrCV. Here we could see an example for the NMR solvent. So if we look into the description below, we could see that now it's a molecular entity that has a role in NMR solvent. So we have these axiomatic definitions. The list is enriched with more solvents, and all these compounds come from KBio with better chemical annotations. And similar work have been done for the reference compounds. We have collected them from IUPAC recommendations and grouped them based on the nuclei. And again, they were submitted to KBI and reported from there with better axiomatic definitions. Other than contributing to KBI, we have contributed directly to nmrCV when it comes to the instruments manufacturers. So first, we tried to align the hierarchy with CHMO, which is done now, and also we have curated the list of manufacturers, and this also affects the instruments themselves, not only the manufacturers, and now they have better linking with each other. And last, we have the pulse sequence, and we are currently focusing on the hierarchy there, so it's a little bit mixed in nmrCV, and we are trying to restructure it based on the dimensionality and also on the pulse technique, but this is still work in progress. And actually, that's all the updates that we have in nmrCV. I hope I'm on time. Okay, thank you very much.